This could be anywhere, this hospital. The quiet here can be deceptive. It is a hall of great hope, a battlefield, and that is worth remembering. It is worth remembering how many diseases have here been conquered. Consider the triumphs a moment. Over diabetes, 30 years ago, a slow death. Then Toronto's Banting and Best found the treatment, insulin. Meningitis, Fleming and penicillin. Victory over lockjaw. Yesterday, an accidental scratch and lockjaw killed. Then the Japanese Kitasato found the answer. Pernicious anemia, death once. From Boston came the life-saving discoveries of Minot, Murphy, and Whipple. And today, science turns to the most baffling disease yet to be conquered.
Is that an artifact there, Ross?
Probably macerated a bit in preparation.
Came in a few days ago. Malignant. Just below the cheekbone.
Occlusion body stained well, Ross?
Yes.
Three scientists looking at a lantern slide, a magnified photograph of a thin cross-section of life removed from a man.
Oh.
Mr. Davis, come in, won't you?
Thank you.
How do you feel today?
Very well, thank you.
That's fine. Some of my colleagues would like to have a look at you. Now, this is Dr. McVicker and Dr. Rom.
Matter of fact, we've just been having a look at a slide of your specimen.
These gentlemen are research scientists.
Yes.
Oh, will you put your hat and coat on the chair, please? Thank you.
Here is a man being attacked by a baffling disease. To understand it, to overcome it, we must first understand the human body. This body, what is it? How did it begin? It begins with the fertilized human egg, a single pinpoint fragment of life, a cell. In this cell lies the power to grow. This it does by dividing. First into two. 2 into 4, mitosis, the scientist calls it, a fundamental process of life. Into 8, 16, and so on, growing as it divides, growing ultimately into the human embryo. As the embryo matures, these cells develop into special structures. The embryo is composed of many millions of cells, developing into tissues and organs by the time it reaches the 7th week. Some cells will make up the tissues of the hand. Others, those of the eye. Still others, the heart, from the unborn child to the adult. And from the embryo finally emerges the complete adult man, now an organization of billions of cells that have shaped him and that give him life. The delicate network of blood vessels, the veins, the arteries. tireless muscles of the heart, the bones, the glands. Into these and many more, as intricate and marvelous grow the cells, the man is balanced, living, complete. His body has reached an invisible boundary line, and the cells stop growing. But sometimes they don't. Sometimes something happens to start them growing again, uncontrolled, dividing again, outlaws. Breaking all rules of the body of which they are a part, they grow and grow. They divide beyond all normality, pressing on healthy tissues, healthy organs, growing, spreading throughout the body to start new malignant colonies. This is cancer.
It's a very interesting example.
One of the most curable of all cancers.
No pain at all, Mr. Davis?
No. Mr. Davis is one of the lucky ones. 90 chances out of 100 will cure it.
Thank you, Mr. Davis.
Very gratifying. The treatments will begin immediately, Mr. Davis.
Okay, Doctor. Thank you.
Don't worry now.
No.
You chaps going back to Padayat?
Yes, I am.
Thanks for coming
So
in. Right.
Bye, Ross.
Goodbye, Ram.
Why should the cancer problem be so difficult? It's a matter of a cell that won't stop growing. We know that. Why not? Why can't we find the reason? The world's best minds, backed by millions in research funds, are at work on the problem. Why is it taking so long? Why is the answer so difficult? It is long and it is difficult because this tiny cell, this microscopic unit of life, so small the naked eye cannot see it, this is a very world in itself, a universe to be explored. Science is piercing deep into this universe, discovering within it new constellations, exploring its nature and its force. Every avenue of research, tissue culture, genetics, biochemistry, physics, all are converging on the secrets of the cell. Because here, in this pinpoint world, yet so vast and challenging to the imagination, is locked the mystery of life and the riddle of cancer. Alive in this flask is a tiny bit of flesh taken from a mouse. Long after the animal has ceased to be, the bit of flesh removed from its body can be kept living and growing, almost immortal. Work with such living animal cells is basic today in cancer research. For his experiments in tissue culture, the scientist can grow normal tissue as well as abnormal. Cancer cells have been grown in glass without losing their destructive, malignant qualities. Transferred to a suitable animal, they would kill it. But these bits of tissue, which once were a part of a living body, must now live outside that body in laboratory flasks. The vital food solutions that will keep them alive must be given them in sterile chambers, completely free of germs. Temperature and humidity must be strictly controlled. A single mistake in technique can destroy months of work. Tissue can be grown in eggs also, again under controlled conditions. The cancerous tumor is injected into a fertilized egg. Then, as the chick embryo develops during incubation, the tumor feeds upon it. In this field of tissue culture, scientists can observe, among other things, the effect various chemicals have on cancer. These effects can be measured by recording the change in size of the growing cell mass. The tissue is placed in a kind of projector, and its shadow outline is traced at different stages. From this, the scientist computes the rate of growth. to find ways of arresting the growth of the cancer cell. This is the goal. These newborn mice will have cancer. 90% of their offspring will also have cancer. But these mice, so useful in genetics research, are pure strains, the result of generations of inbreeding, brothers mated to sisters, and then sons to daughters. Until now, their chances of having cancer are almost completely predictable.
Here, Kay, take a look at this one.
At the same time, a mouse can be bred that will have little chance of ever developing cancer. With pure animal strains, science can investigate the question of heredity in this disease. But men are not mice. Between one human generation and the next, there is no precisely known relationship in cancer. Yet, in his animal room, the inquiring mind may find the clue that will help to unlock the mystery of cancer in man. To learn from mice, the scientist must study them for years. But to follow the entire lifespan of the tiny fruit fly, only a few weeks are required. Searching into the mechanics of heredity, the scientist has found that the chromosomes, the carriers of heredity, can be changed by forces outside the cell. The normal fly can be placed under a bombardment of X-rays. These rays strike like a kind of electric hammer. This can affect the chromosomes so deeply that following generations may behave differently, look different. Wing shapes changed from the normal, freaks. And these mutations, as they are called, can occur in many animal species, in mice, for example. Somersaulters with new movement habits, circlers, and the new characteristics of these animals may now be passed on from generation to generation. Perhaps cancer is due to something that changes the chromosomes of the normal cell. Genetics research is throwing new light on the problem of abnormal growth. In these vibrating glass containers are bits of living tissue. With this apparatus measuring the gases they take in and give off, the biochemist learns about the breathing of tumor cells. It is part of the investigation being carried on in biochemistry labs all over the world. The inquiry into the life processes of living cells, normal cells, and cancer cells.
See when you're ready, Barbara.
You seen Reed's article in the new journal, the tracer technique one?
Yeah, I looked at it over the weekend. Nice bit of research.
Yeah, he's a good man.
This is the daily round of the lab. People work, talk, they have their lunch, but surrounding them always is the purpose of their search. To find the answer, to advance the attack, to advance the ultimate strategy, the encirclement and destruction of the malignant cell. This is the final goal in every branch of cancer research. This, the goal of every scientist in the cancer field.
Oh, well, put a Band-Aid on. He'll be all right in the morning. What bill? I paid that bill at the beginning of the month.
From his first lesson in kindergarten, it takes perhaps 20 years of study to make a biochemist, a geneticist, a botanist, a physicist, to make a scientist. He is a man like other men, but also he is a man whose mind has been specially tuned, his imagination keenly alerted. Within him, he has stored a vast fund of knowledge drawn from the scientific harvest of the world. And within him, restless, stirs the problem to be solved. The problem of cancer, the riddle within the cell. There are no hours for the men and women in this fight. There is only the steady search. Each day, Each night, all night long, in the late, dark quiet of the laboratory, the attack is advanced. And men like this, in places like this, are carrying the fight to the mysterious territory of the cell. The lights of science are piercing its darkness, and as the problems are exposed and the answers emerge, so is the hope revealed by men like this, in places like this, in Montreal and Washington, New York and Paris, London, Rome, Geneva, Stockholm. And because of the hope science has given him in the steady progress of its attack, a man can approach the thought of treatment with confidence. Whole areas have already been recaptured from the territory of death. The majority of cancer cases brought to medical care this year can be effectively treated. In the unseen laboratories behind hospital walls, scientists are working with sensitive tools that may lead to additional weapons for healing. The exploration of known and new fields continues. There is radium, so powerful lead walls must shield it. Little tubes of it applied near the cancer growth. Its shattering rays will penetrate the tumor, destroying the malignant cells. There are radioactive isotopes, atomic research turned to the uses of man. Some cancers of the thyroid gland, for example, have shown signs of yielding to this new technique. There is the Geiger counter itself. Its electric crackle, a yardstick to measure and follow radioactive compounds within the body. Radioactive iodine, carbon, sodium, phosphorus. It is against this background of research that the patient with cancer is being treated. In the field of X-ray therapy, multi-million voltage weapons with ever more effective radiation for destroying cancer cells are being tested on models of men.
I'm not going to feel anything at all, Mr. Davis. I'm just going to position this machine and bring the cone right down till it's resting in your cheek. Now, you tell me if this is too tight, Mr. Davis.
It's all right, I know.
And side by side with the X-ray that is curing Mr. Davis are the great advances of modern surgery. The earlier a patient with cancer can be brought to treatment, the greater his opportunity for cure. There is much that can be done now that was impossible even a few years ago. We have made more progress in the past 5 years than in all of the past 25. More people are being saved each year. And the power of our attack mounts steadily in this battle for life. And to the battle lines are coming the new recruits, the men and women from our universities and colleges, young scientists equipped and ready for the challenge. And in readiness for the fight that awaits them, they have drawn their weapons, studied the tactics, no strangers to the target on which they have so long been briefed.
We come again this morning to our discussion of the cell. Can we have the projection, please? I would ask you to bear in mind that we're dealing here with an enormous problem, the problem of life itself.
Remember then the diseases that have here been conquered. Pneumonia, conquered. Typhoid, syphilis, all conquered. And cancer? There are cures to mark our progress. This is the measure of our hope. Each day we make more progress. Each day we advance.